Hi guys, in this video I will explain you what is the word count problem and how to write Spark code. Also I'll try to show you difference between FLATMAP and map. So this is the first practical problem we are doing. Before that we are already did some theory things. So first time we'll try to see in practical way. So this is the basic program. So word count problem. What is the problem statement? So we have a one string. Okay, so we have to find occurrence of each word. So if you see this, so we have to, like, if you can see the I, how many times I present in the string? Only 4 times. Here on 1, 2, 3, 4. Like 1, 2, 3, 4. How many times like word is present in the string? 1, 2, 3, 4. That's why it is 4. Okay, 4 present. So like is present only 4 times in the string. For a Joey only present 1 times. Carrie Dana present only 1 times. Okay. And Amy present only 1 times. For Carrie also we have to write like this. Carrie 1 times. So that will be the output of this. If I give this input, output will be like this. So how we can do this? So for that we have to write pyspark code. So I created one file, words file, okay, word.txt and word.txt and tried to, and in that word.txt I write this line. Okay, I like Joey, I like Gary. So in this word.txt we have one single line. Okay, and from this line we have to find out occurrence of each word. So let's do it. So for this we have to write pyspark code. Now I'll try to import SparkContext from pyspark. Import SparkContext. Okay, SparkContext. So SparkContext is a class, and then we have to create one. We have to create SparkContext. We are already imported it. We have to create SparkContext so that we can get entry. We can get entry into Spark cluster. So this is the entry point of Spark cluster. So for that, to create a SparkContext, we have to call this. We have to create a object of this class, SparkContext class, and there we have to mention some value. Okay, so this local and the star means we are saying that we are saying to our Spark cluster that we are executing this Spark job in our local environment. That's why we are writing local, and the star means we are saying that for this Spark job, Spark cluster can use every course of this laptop. So if in your laptop if you have a 4 course for this job, Spark engine can use all of the core. Means if you have a 4 course, Spark engine can use 4 course. So we are giving all resources to this Spark job. That's why we are writing star. And we are for local means we are executing this job in local environment. Then you have to give a like app name, means job name. What is the name of the job? Name of the job is word count. Okay, you can write anything here according to your wish, but you cannot change this. Okay, because we are running in local, so you have to mention this local star. Okay, so if you are running in some not local, some environment, you have to do like this. So that's it. So we are already created on SparkContext. So name of the SparkContext is sc. So then what we'll do, we'll try to load our words.txt file, this txt file, in our Spark context, okay, in our Spark cluster. So now this will be our RDD1, okay, initial RDD. So we are sc.text file, and we have to give the path name of our okay. So this is the path name of this words.txt. So if you go to this file, you'll right click and try to go to properties and then copy it. You can find that path of that the location of that file. Then you go there and try to paste here. Okay, if you paste this, so it will be like this. So you have to erase this and you have to like this. You have to do like this. And then slash your file name. File name is words.txt. That's like you have to do it. So we already provided this sc.txt and path. Okay, path name, file name to this our Spark context. So it will try to load this file, not initial. If I face any action, then it will try to load this file. Okay, so you must remember there are two operations, transformation and action. So we have a we have a string like this. So first what we will do, if you want to try to count all occurrence of each word, then first you have to try to split this line. Okay, you have to split every line. We have to split this line and we have to separate these things. Okay, I like you, you have to separate all of those things. So if we try to split a line, then what we can do, then we have to do like this. Okay, observe. So we are try to find words, how many words is there. Okay, first, then we can think about count things. So let's think. So what we'll do, so initial rdd dot FLATMAP, this is a function, and here we have to write one lambda function lambda x equal to x dot split z split. So here we are what we are trying to do, we are trying to split this line using this space. So if we face any space, so so program will split this line as a two word. So you can see this space. So this is the space is a delimiter. Okay, this space is a delimiter. So it will try to split this string when they'll observe any space between two words. It will try to split this. So space is a delimiter. So after this, how my output look like this, that you have to show, that we have to see. For this, what we'll do, we'll try to print this word, because if you see this FLATMAP function is a transformation, so we cannot print this word. Okay, so for this we have to put some action, we have to write some action. So for this we are writing this collect action. So collect is action. So it will try to load all of this thing. Okay, it will try to collect every information like this. So if I try to print this, like if I run this, we will get output like this. let it be wait. So what is the meaning of the flat map? Flat map will try to flatten the data. Okay, so the concept is like if you give any single input, okay, to the flat map, it will try to, like, if your identity has three element, see, if in your identity there's only one element, so if you use flat map function, you will get another identity, but that identity can have more than 0 1, more than n, okay, elements in that identity. So number of input equal to number of output will not be equivalent. So if you pass, so you will try to like you will get more better understanding if you see the output. So see, so we are passed one only string. So after the splitting this, that after splitting that line, we are getting output like this. Okay, so what you're doing, it will try to flattering our data. It will try to give multiple output. Like for a map, if you know map function, if you give one output, it will give a one output, like one-to-one mapping. For flat map, it will one to many mapping. So it will try to go to each element of this. The map function will try to go to each element of this word and provide you multiple output. So this is one single line, and here we are getting multiple output. Okay, multiple output as a list for. Okay, so that is the importance of the flat. So you can know more about this flat in PysparK article. If you go to the internet, you will try to find flat versus map versus flat, so you'll get some official document that will be better. Okay, so it will try to flatten the data. So we'll, after this flat map function, we wrote some lambda lambda function. So here we are saying that go to, so we are passing x as a input. Okay, we're trying to pass this string as a single input, and so this function will try to iterate that string and splitting that string when they're finding delimiter equal to space. That time it is splitting that this line. So now we got like this. Now what you have to do, you have to find occurrence of each line. For that, how we can do this? For this, we have words RDD. So you have to, like, word here, we are getting on DD words dot what does map function will do. Here also we'll try to write one lambda function, and here what we'll do. So here we are saying iterate this list and give me output like this, I comma 1 like comma 1. That's why we are saying iterate, giving me one tuple, and in the tuple the format will be like this, like comma 1 joey comma 1, like this. So if I try to print this word pair, how can do this? Again I have to use this. So you don't have to do like this. I am doing this line to show you the output so that you can get better understanding. Okay, now if I do word dot pair, now if I run this, map also transformation, but the main thing about map is many to many transformation. Like if you give, sorry, one to one, so if you give one out input, it will give a one input. For flat map, if you get one input, it will give multiple output. Okay, so if you provided the initial additive on our identity where we loaded this that our string, that file. So in this additive we have a one element. Okay, and one element means we have a whole string as a one element. But when you are creating this additive, when you are applying this FLATMAP function, it will taking this initial additive, and in this additive we have only one file, only one string. But one string means one element. But when you are receiving this, when you are applying this FLATMAP function, or receiving this this new additive, we are getting one additive with multiple elements. So you can see after applying this map function, and we are getting like this: I comma 1 like comma j comma 1 I comma 1 like comma 1. So this lambda function is try to iterate this list, and for every word it will try to assigning like this, try to assigning one like this, and creating one pair. So it is a tuple. It is a tuple. We try to create a tuple with one for every word. So we are created a list of tuples. Okay. So we are got like this. So now what we can do, we can try to find similar key, like I is present is here, I is present is here, present here, I also here. So we'll try to find similar key and try to add it. Okay. So for this, what we can do this. So for that we can do like this, that we can use reduceBykey. Okay. ReduceBykey also transformation. So map, FLATMAP, and reduceBykey is a transformation, and collect is a action. So for that we have to use we are getting another additive result. Here we are using this add what.pr as our input additive. Here we are applying this reduceBykey, and inside reduceBykey we have to write another lambda function. So lambda x comma x lambda a comma b plus a plus b. So here what we are saying, that iterate this initial iterate this what dot pair. So we are applying this reduce function to this what dot pair additive. So we are saying that we have to iterate this list of tuple. So this function will, this lambda, this reduceBykey, sorry, this will be reduceBykey, not reduce. So reduceBykey. So this reduceBykey function will try to iterate this function, iterate this list of tuples. This one, this what dot pair rdd. It will try to iterate, and it will try to find similar key. Okay, similar key means reduce just similar. This I is just similar. This I is just similar. It will try to reduce. It will try to reduce by key means it will try to add this i's value. This, so it will try to add every word's value. Okay, so what I am trying to say, so if I try to print it, it will, you can understand. So print word dot, sorry, result dot cell dot collect. So for our case, key is this and value is this. So in this function we'll try to say took similar key, so it is taking this and this two similar key and try to add their value. Okay, so it is saying took similar key and try to add their value and give us input, give us output. So if I try to print this, so it will get like this. sorry, we have to provide this collect. When you're saying this stage means they are doing some transformation. Okay, so if you see this output, like is 5 times, Joe is 5 times, so it will try to reduce this value, it will try to add this value by key. Okay, so you now you will get you got this output. Okay, so that is the word count problem. Again, I will explain. You can remove these things. So see, when we are loading this file, okay, when you are loading this file in this initial additive, we have this string only. Okay, we have only this string. Now, when we will try to FLATMAP this, we will get like this. We will get this like this. I like, then Emmy. I like Emmy, or I will get I like Dana, like this. So we'll get like this. Now when you will try to implement this map function, this map function will iterate this list and it will iterate every word. Okay, it will go in by every element, iterate by every element. It will go individual each word and try to create a list. Like this. So we are saying this is our input. So we'll give this list as an input. We are saying that iterate this list, and for every word we have to create a pair. Okay, x comma 1. So that's why we are getting like this. So that this FLATMAP map function will create pair with every word. Okay, so we are assigning 1 to every word, because I present only 1 times. Okay, here, that's why we are creating a pair. And here also we'll get this Emmy comma 1, I comma 1, like this. We will get like this. So I am not writing full strings value, so I am giving some example. So we will get like this. And then what we are saying that, and for after then also I have like, let's think I have I comma 1, because if I try to split this file, we'll get 5 times. So there will be multiple I will be there in the string. I am not writing full content because I have a time constant. So we will get like this. Now what we are saying, then we are using the reduceBykey. reduceBykey is a transformation. Okay, so reduceBykey function, and here inside this function we are try to write, we wrote one lambda function. So what is in this lambda function, we are saying take 2 input and add those 2 input. That's it. And this is a reduceBykey. So this function will go to this this reduceBykey function will go to this. It will take this list as a input. It will try to iterate every tuple. Okay, it will try to iterate every tuple. And when this function will check, see this, we have a same key. It will try to add the key. Okay, it will try to add like this. It will take first to same key. So we get first same key is I is, this is the first same key value. Okay, so this function will try to do like this. It will take this I and it will try to add this. Okay, and try to add like this. To add, like, it will try to do like this. This function will do like this. And after doing like this, we got a list like this. Okay, so it will try to add 2 I will try to add this two tuple, two pair. After then our list will be look like this. So it is I am showing you internal working, how this function internally works. Then the remaining part we have only this and this. Again this function will try to find same key. So you see this is the same key, this is we can this is the same key. Then again this reduce by key function, the reduce by key transformation will try to add things with this. So it will do like this, it will do sorry. So again this reduce by key transformation will do like this. It will try to find same key. So I is the same key, here is this I, this is the same key. So internally it will code like this, I comma 3 and then Emmy comma 1. So this is internal working. It will always try to find two same key and then it will add the value of that same key. It will try to add the value of the same key. That's how we can get. That's how reduce by key is working. So this is the example of word count problem, and we have to write the code like this. So if you want to know more about our FLATMAP and reduceBykey, you can go to official documentation of this PySpark. So difference you can find that. So all of this, the reduceBykey, the FLATMAP reduceBykey is a transformation, and this collect is a action. So it will try to collect every, it will try to load every information to this result. Okay, and we are printing this. And one example, difference between map and flat and map and flat map means between difference between map and flat map. So when we are using flat map is a one-to-one mapping. Sorry, flat map is a one-to-many mapping. So if you give any identity with one element, it will give you identity with 0 or more than one element. Okay. So we only gave only one string and we are getting as a list of many input elements. So that's the difference. It will try to flatter the data. And map, it will take one input. If you give the n input, it will give you n output. Means we are giving every word as a input here, and we are giving every word as a input here, and we are getting every word is a pair. Okay, so we are giving every word as a input. We are getting every word as a output. So it is a, if you give n inputs, it will give n outputs. That's the map. And reduceBy will try to match every, if it's reduceBy, reduceBy what will do, reduceBy will try to find same key. Okay, it will, if you find same key, it will try to match the value of that same key, try to add that value of the same key. So that's it in this video. I tried to explain you what is the word count problem. Just wrote this function by yourself, okay, and try to play. Okay, try to see the what is the type of the return. So you can try to see print initial identity. Let's see if I get, like, try to play with this code and try to understand what is going on. So that's how I learned it. So you have to invalid syntax. Okay, because for this now if I run this, So for map and FLATMAP, I'll show you one, like I'll show you this FLATMAP versus map. From where you can study it. Go there. This Spark by example. This is the official document of the pyspark or Spark. You can go there and study it, or also you can go. You can study from. It's a Java thing. Okay. If you have to study from here, Spark map and FLATMAP. Okay. You can study from here. This is the official documentation. You will get better understanding. Now see this. See, when we are trying to print this initial RDD, just after loading this file, we have a list like this. And when this stage, I will explain you what is the stage meanings of the stage later. Okay, ignore this stage part. I will explain later what is the meaning of this. And then when we are applying this FLATMAP, okay, we are getting output like this. We are getting output like this, like Emmy, like Dana. So we are splitting this file. Okay, so we are giving only one input. We are getting only one input element, and we are getting multiple output elements. You can see in this list we have only one element as a string, but when we will run this code, and we can find, so better thing will be we print it. Okay, we print it, we will get better understanding. Okay, initial DD. So now let me run once again. See the output of this program. So when you're loading this file, we have only one element in this list. Okay, after loading this text file, we are getting this string as a list. Okay, we are getting that's this string as a one list inside this just one element on string element in this list. So we are passing this list with one element to this FLATMAP function. Okay, this FLATMAP function. This FLATMAP function, and we are after passing this FLATMAP function, we are passing this one element from this string from this list. We are getting like this. So we are getting multiple element. Joey, I like we are splitting this string and we are getting multiple element with this string with this list, one list. And after applying map, we are getting like this. So if you can observe, we are getting same number of element. How many number of elements present? What element present is there? We are getting same number of element here in this list, but we are creating one pair. That's it. So main difference between map and FLATMAP is, so if you passing single element to the FLATMAP function, it will give you multiple element. So if you're passing one additive with single element, it can give you after applying FLATMAP, that FLATMAP will give you additive with multiple elements. For map, in case of map, so if you're passing one RDD with 5 elements, RDD means you can think list. Okay. So if you're passing one RDD on list with 5 elements, after applying map function, you will get same number of elements in RDD. We will get one list with same number of elements. That's the difference between map and FLATMAP. And then we are applying reduceBykey function. Okay, and adding every key, every value of every key. That's it. So that's how we experiment with code and try to understand. I'll provide this code snippet below this video description, so you can check out from in that section. Okay, that's it in this video. I think you get this. You able to understand what is the word count problem and how the map and how FLATMAP is working internally. That's it. And that's it in this video. See you in the next video. Bye.